There is a number floating around the fishing world right now that gets quoted constantly by people who have never read the paper it came from. 0.81. That is the Gini coefficient for the California steelhead fishery, measured across 11 years of mandatory angler report cards. And if you have never heard the phrase Gini coefficient before, here is everything you need to know about it. It is a number economists use to measure inequality. 0 means everyone gets exactly the same share. 1 means a single person gets everything, and everybody else gets nothing. 0.81 is not a normal number. It appears to be one of the most unequal fisheries anyone has ever formally measured. A small core of anglers caught fish trip after trip, and an enormous share of the people holding a license caught nothing at all. The moment that number escaped into the angling world, a story got welded onto it. You have heard the story. It goes, "See, the old saying was true. 10% of anglers catch 90% of the fish, and the reason is skill. The top 10% are simply better than you are." I want to spend the next 20 minutes taking that story apart. Not because the number is fake. The number is real. It is the story bolted on top of it that falls apart the second you push on it. And when you push on it, and then go read what fisheries science actually found when it went hunting for angler skill under controlled conditions, you end up somewhere genuinely strange. Somewhere that changes what you think you are even doing out there. So here is where we are going. By the end of this video, I want you to stop thinking of yourself as a person who catches fish. I want you to start thinking of yourself as a variable, a single letter in an equation that fisheries scientists have been writing about you, modeling you with, and arguing over for the better part of 70 years. You are not the fisherman in this story, you are the coefficient. Let me show you the equation, because it is almost insultingly simple, and once you see it, you cannot unsee it. Catch equals effort, times Q, times N. N is the number of fish. Effort is how long you fished. And Q is the catchability coefficient. Q is the probability that any given fish in that water ends up on your line, per unit of effort you spend. That is it. That is the whole model that sits underneath every creel survey, every stock assessment, every fisheries management decision made in your state. Now look at where you live in that equation. You do not control N. You did not stock the lake. You do not control the weather, the forage base, or the spawn. Effort you control, but effort is just hours, and hours are boring. You are Q. Everything you have ever done as an angler, every decision, every cast, every rod you bought, every spot you drove 2 hours to reach, all of it collapses into one lowercase letter in a fisheries model. And here is the part that should bother you. In stock assessment work, Q is what scientists call a nuisance parameter. It is the messy, unstable, poorly behaved term that ruins their data. You are the noise in their model, and you are the only thing in yours. So let us take Q apart and find out where in that letter your skill is actually hiding, because the answer is not where you think, and I am going to show you the experiment that proves it. But first, we have to deal with 0.81, because the catch inequality number does not mean what the internet thinks it means. In 2011, a researcher named David Seekell, then in the Department of Environmental Sciences at the University of Virginia, published a paper in the North American Journal of Fisheries Management with a title that reads like a shot across the bow. Recreational freshwater angler success is not significantly different from a random catch model. Read that again. Seekell took long-term angler log data from 6 lakes in Montana, covering largemouth bass and lake trout, plus creel survey data from the lower Current River in Missouri. He ran the inequality numbers. Montana came back with Gini coefficients between 0.26 and 0.64. The Current River came back at 0.71, highly unequal. Exactly the pattern everybody points at as proof of skill. Then he tested those distributions against a model in which catch is determined by pure chance. They were not significantly different. Sit with that. The lopsided, dramatic, 10% catch 90% distribution that the entire fishing internet treats as a monument to angler skill was statistically indistinguishable from what you would get if fish were handed out at random. And once you understand why, you will never look at a hot streak the same way again. Catching a fish is a rare event, rare and clumped. Suppose every angler on a given lake has an identical, modest chance of hooking a fish in any given hour. Not a good chance, a realistic one. Run that forward over a 4-hour trip and the math does something people find deeply unintuitive. Most anglers go home with 0, a few go home with 2 or 3, and nobody in that scenario has any skill at all because we define them as identical. Now stack a whole season on top. Total catch across a year is dominated by one thing above all others, and it is not talent. It is how many days you went. If 10% of the license holders in a state do 60% of the fishing, they will catch most of the fish, and the Gini coefficient will scream inequality, and not one single point of that inequality has to come from skill. There is a second piece of evidence here that almost nobody quotes correctly. There is a long-term study on a trout stream in southeastern New York with complete creel records covering 20 years, every fish for every angler. Catch inequality in that fishery did change over time, but when the authors decomposed it, the increase was driven by variation between trips, not variation between anglers. The angler-to-angler spread stayed flat, which is a very polite academic way of saying the variance was in the days, not in the people. So here is the first thing I want you to take out of this video, and it is going to sound like I am about to tell you that skill does not exist. I am not. Stay with me. What I am telling you is that the famous statistic everyone uses to prove skill exists proves nothing of the kind. It is a real number attached to a false explanation. And if you have been walking around believing that the guy at the ramp with the full live well is 9 times better than you have been reasoning from a number that cannot carry that weight. Which raises the obvious question. Fine, so where is the skill? Does it exist at all? Yes, and in 2018, 2 scientists went and measured it under conditions so tightly controlled that the result is genuinely uncomfortable. Christopher Monk and Robert Arlinghaus, working out of the Leibniz Institute of Freshwater Ecology and Inland Fisheries in Berlin, ran what they called a whole lake reality mining experiment. Their paper is in the Canadian Journal of Fisheries and Aquatic Sciences. Here is what they did. They took a small lake and they surgically implanted acoustic transmitters in 33 large Eurasian perch, fine-scale telemetry. They knew, continuously, where every one of those fish was in 3 dimensions. Then they put anglers on the water, 104 of them, in small groups, varying in self-reported skill from beginner to expert. And they tracked the boats too. So for the entire experiment, they knew where every tagged fish was and where every angler was at the same time. Nobody in the history of recreational fishing had ever been able to see both halves of the encounter at once. And I want to be straight with you about the limits here, because that matters more to me than a clean soundbite. This was Eurasian perch in a German lake. That is not a largemouth in a Texas impoundment. Species differ, systems differ. But what this experiment measured was not a perch fact. It was a structural fact about how angling encounters work. And that structure does not stop at the Atlantic. They found 2 things. The first, whether a perch got caught, was strongly tied to a repeatable habitat choice behavior of the fish, not its swimming activity, not its raw boldness as a personality trait, where that individual fish repeatedly chose to live. And critically, the highly vulnerable fish were caught all over the lake, not just in their preferred water. Some fish were simply catchable, and they carried that with them everywhere they went. The fish decides who gets to catch it, before you ever pick a rod up. The second finding is the one that should rewire you. Catch per unit effort (DID) go up with angler skill. Skill is real. It showed up in the data, but when they went looking for the mechanism, it was not what anyone expected. The skill effect was unrelated to lure choice, and the skill effect was unrelated to the angler's ability to encounter perch. Read that one more time. The better anglers were not better at finding the fish, and they were not winning through the tackle box. They encountered roughly the same fish as everybody else. They threw things that did not statistically distinguish them, and they still caught more. The lake handed everybody a similar set of encounters. The difference was what happened after the encounter. Now go stand in the fishing aisle of any big box store in America and tell me what that industry is selling you. It is selling you term 1 and term 2. It is selling you the encounter, and it is selling you the lure. Location, location, location. New color, new action, new scent. And the one controlled experiment that could actually see inside the encounter found the skill signal somewhere else entirely. So let us finish taking Q apart, because now the decomposition writes itself. Q is not one thing. Q is a chain. The probability that you encounter a fish, multiplied by the probability that the fish commits to your bait, multiplied by the probability that you convert that commitment into a fish in your hand. Encounter, commitment, conversion. The industry sells the first two. The evidence found the signal in the third. And conversion is deeply, profoundly unglamorous. It is hook points. It is hook set geometry and the angle of your line. It is slack management on the fall. It is what you do in the 2 seconds when the fish has already made its decision and now the whole thing is on you. Nobody is running a 15-second pre-roll ad about hook sharpness. And that is exactly why the edge lives there. But we are only halfway, because there is something wrong with N as well. And it is worse. You think N is the number of fish in the lake. It is not. N, for you, is the number of catchable fish in the lake. And those are wildly different numbers. Ridge Lake, Coles County, Illinois. A small research impoundment inside Fox Ridge State Park. Starting in the 1970s, David Philip and colleagues at the University of Illinois and the Illinois Natural History Survey ran one of the most extraordinary angling experiments ever attempted, and the results were published in the Transactions of the American Fisheries Society. Fishing on that lake was totally controlled. Anglers reserved time slots. Every largemouth bass that got caught went into a live well, got measured, got tagged, and got released. 4 consecutive seasons of that. A complete capture history for a whole population. Thousands of captures. Some individual bass got caught over and over. One fish was caught 3 times in the first 2 days. Another one was caught 16 times in a single year. And then they drained the lake. Every bass in there came out. Roughly 1,785 fish. And when they cross-checked the tags against the drained population, they found that about 200 of those bass had never been caught. Not once, not in 4 seasons of concentrated, documented, controlled angling. Those fish lived in the same water as the bass that got hooked 16 times in a year. Same forage, same cover, same lures going over their heads. And they were, functionally, invisible. Then Philip's team did the thing that turns a curiosity into a law. They took the bass that had been caught 4 or more times and bred them together. And they took the bass that had never been caught and bred them together. 2 lines. High vulnerability, low vulnerability. 3 generations later, the lines held. The offspring of the easy fish were easy. The offspring of the ghosts were ghosts. Realized heritability came out at roughly 0.15. Vulnerability to angling is a heritable trait. It is written in the fish, not in your tackle box. And it is not only genetic, it is learned on top of that. Askey, Richards, Post, and Parkinson, in the North American Journal of Fisheries Management, experimentally fished 5 small rainbow trout lakes in interior British Columbia. Everything released, nothing killed, nothing removed. Catch rates collapsed within 7 to 10 days. The fish were all still there, every single one of them. The best-fitting model of what happened describes a population containing a pool of highly catchable individuals who got caught fast and then learned to avoid hooks. Same fish, same lake. Same number of them. Catchability, gone. So put those 2 together and look at what you are actually standing in front of when you look at a lake. You have never once fished a lake in your life. You have fished the catchable fraction of a lake. A subset that is partly genetic, partly learned, that depletes within days under pressure, and that refills slowly. And every angler who fished that water before you this week has already been shaving it down. The 10 and the 90 start looking very different now, don't they? Which brings us to the last, and I think the most dangerous idea in this whole video. Your catch rate is a broken instrument, and you have been using it to grade yourself for years. In fisheries science, there is a phenomenon called hyperstability. Brad Erisman and colleagues put a name on it that is hard to improve on. They called it the illusion of plenty. Their study, in the Canadian Journal of Fisheries and Aquatic Sciences, looked at barred sand bass and kelp bass in Southern California. Both stocks collapsed. And catch per unit effort stayed high, almost all the way down. The fishery felt fine right up until it did not, because those fish aggregate, and fishermen target aggregations, so as the population shrank, the fishing did not. This is not a saltwater curiosity. Work on steelhead across 14 streams in British Columbia found hyperstability in every single one. The scale of the distortion is brutal. Cut a population in half, and catches might only fall by about 40%, which means anyone reading catch rate as a proxy for abundance will look at a half-empty river and conclude it is mostly full. And in freshwater there is a second mechanism stacked on top, and it is about you. Van Porten, Walters and Ward described what is called effort sorting. As a lake gets tougher, the casual anglers quit first. They stop showing up. The people still out there are the skilled ones. So the average measured catch rate on that lake stays propped up, not because the fish came back, but because the sample of anglers changed. Now bring it home. Catch per unit effort is a compressed, non-linear, biased instrument for measuring what is under the boat. And catch per unit effort is exactly the instrument you use, in your head, to grade every decision you make on the water. You threw a new bait, you caught a fish, you concluded the bait works. You went to a spot, you caught a fish, you concluded the spot holds fish. You are running a scientific inference on an instrument that fisheries scientists explicitly warn should be given low weight whenever independent data are available. "I caught fish there" is one of the weakest sentences in all of angling. It is barely evidence about the lake. And it is almost no evidence at all about your decision. There is one more layer, and it is the one you can act on tomorrow morning, so listen closely. If skill is not primarily in the lure, and the catchable pool depletes locally within days, then catch inequality should have a shape on the map. And it does. It has a name. The halo of depletion. Wilson and colleagues, in the Journal of Applied Ecology, described how social and ecological feedbacks drive spatial exploitation in freshwater fisheries. Access points concentrate effort. Effort strips out the catchable fraction closest to the ramp, and what remains is a gradient. The further and harder it is to reach a piece of water, the more of the catchable population is still sitting there, uneducated, unselected, unpressured. Which means a serious portion of what everybody calls skill is not a mind, it is a map. The angler with the full live well may not be reading the fish better than you. He may simply be standing outside the halo. And now for the uncomfortable question. If all of this is true, and most of it has been sitting in peer-reviewed journals for decades, why does the fishing world believe almost the exact opposite? The answer is in a 1948 paper that has nothing to do with fish. B.F. Skinner published a study in the Journal of Experimental Psychology titled Superstition in the Pigeon. He put hungry pigeons in boxes and delivered food on a timer, completely independent of anything the birds did, and the pigeons developed rituals, turning circles, bobbing heads, swinging their bodies to one side, because whatever they happened to be doing when the food arrived got reinforced. Reward that arrives unpredictably, on a schedule you do not control, is the single most powerful generator of persistent behavior and false causal belief that psychology has ever documented. Now describe fishing to me. Unpredictable, intermittent, rare, enormously rewarding when it lands. It is the purest variable ratio reinforcement schedule in American recreation, and you are running causal inference on it, with a sample size of one trip. Fishing does not just fail to teach you. Fishing manufactures false belief, industrially, as a byproduct of its own reward structure, and then a several billion-dollar industry packages those beliefs and sells them back to you in a blister pack. I want to be honest that this channel is not exempt from that. Neither am I. That is exactly why I care more about the mechanism than the tip. A tip you cannot test is just a pigeon turning circles. So, Monday morning, what do you actually do with this? Rebuild Q in order of leverage. 1. Count effort honestly, not trips, hours. A meaningful chunk of the entire 10 and 90 gap is here, and it is the least romantic finding in fisheries science. 2. Get outside the halo. Distance and difficulty from the access point is a variable you control completely. It costs nothing, and it is one of the few things in this video with a documented spatial gradient behind it. 3. Stop over-optimizing the term where the controlled experiment could not find a skill signal. I am not telling you lure choice is 0. I am telling you it was small enough to vanish into the noise while conversion did not. Spend your attention accordingly. 4. Own conversion. Sharpen hooks obsessively. Fix your hook set. Manage slack on the fall. This is the least sexy paragraph in this script, and it is the one the data pointed at. 5. Rotate water, not just baits. The catchable fraction in front of you depletes on a timescale of days, not seasons. 6. Log encounters, not catches. Follows. Short strikes, blow-ups you missed, fish that ate and came off. That is the only way to estimate your own cue instead of your own luck, because catch alone is too noisy to teach you anything. 7. Treat your confidence bait as a hypothesis you have never once tested. And before you go anywhere with any of this, check your state and local regulations. Seasons, limits, gear restrictions, and access rules vary enormously, and everything you just heard about heritable vulnerability, hook learning, and depletion halos is precisely why those rules exist. You are not fishing a static resource. You are fishing a population that remembers, evolves, and thins from the ramp outward. So here is where we land. The 10% do catch most of the fish. That part is true. But they are not doing it because they cracked a code you have not. A large share of that gap is effort, geography, and the raw statistics of rare events. What is left over, the real, measured, replicable skill, turned out to be sitting in the part of the process nobody films, nobody sells, and nobody argues about at the ramp. You are not fighting the fish. You are a term in an equation. And the fish, it turns out, helped write it. Now I want to hear from you. And I want you to be specific, because I am going to defend a position here that most of the comment section is going to hate. Here it is. For the overwhelming majority of you, lure color has never once been the reason. Not once. Not on the day you swear it was. So tell me that day. Tell me the exact trip where you are certain the color was the variable, and then tell me how many trips you think you would need, holding everything else constant, before you could actually prove it against chance. And one more, because I want to see if the map theory holds. Tell me how far your single best spot is from the nearest boat ramp or access point. Just a number. I want to see the pattern in the comments, and I will read every one of them.